All right, in the second part of the tangent and cotangent video, we're going to work on graphing cotangent. So it's very similar to graphing tangent. So over here on the left, we have a table of values for tangent, and we know that tangent is equal to sine over cosine. Now we are graphing cotangent, but it's worth looking at this table because cotangent is just the reciprocal of tangent. I didn't leave myself a lot of room to graph here, but if we look at the first row, negative 2 pi. All right, sine of negative 2 pi is 0, cosine negative 2 pi is 1. So therefore, tangent is 0 because tangent is sine over cosine, 0 over 1. Now, cotangent is the reciprocal of tangent. So instead of doing 0 over 1, we would do cosine over sine, 1 over 0, and we get undefined. I'm having trouble writing here. Good. All right. So wherever tangent is 0, cotangent is going to be undefined because the reciprocal of 0 is undefined. And the opposite also works here. So if we look at the next part, all right, the tangent of negative 3 pi over 2 is undefined because sine over cosine is equal to tangent and 1 over 0 is undefined. The reciprocal of that would be 0 over 1, which is 0. So at negative 3 pi over 2, cotangent would be 0. All right, and then this pattern continues. So the tangent of negative pi is 0. So the cotangent of negative pi would be undefined. All right, and we could keep going there. I won't change up the colors anymore. 0, undefined, 0, undefined, 0, undefined. So how would this look on our graph? Well, we have that the cotangent of 0 is undefined. That's because the tangent of 0 is 0. So that means for cotangent, at 0, we're going to have a vertical asymptote. And since the period of cotangent is pi, we're going to have another vertical asymptote pi units later. So the period is pi because if we're graphing y equals the cotangent of x, period is pi over b, and b is 1. And then we divide by 4, and our increment is pi over 4. So this is pi over 4, 2 pi over 4, 3 pi over 4. Now, if we look at the 3 other points, it makes a lot of sense if we think of what the tangent of these values are. All right, so right here in blue is pi over 4. So the tangent of pi over 4 is equal to 1, which means the cotangent of pi over 4 would also equal to 1, because 1 is equal to 1 over 1. And if you flip that, the reciprocal is 1. So wherever tangent would have a high point, cotangent would as well, because they're both equal to 1 for that value that you plug in for the angle. And same thing with the low point. All right, right here would be 3 pi over 4. So the tangent of 3 pi over 4 is, well, that's 135 degrees, 45-degree reference angle. So it's going to be 1, but negative 1 because it's in quadrant 2. So wherever tangent has a low point, cotangent will also have a low point. And then if we look at this point right here, which I'll highlight in orange, right, that's pi over 2. So the tangent of pi over 2 we know is undefined because the sine of pi over 2 is 1, and the cosine of pi over 2 is 0. 1 over 0 is undefined, which means the cotangent of pi over 2 would be the reciprocal of that, 0 over 1, which is 0. So wherever tangent is undefined, has an asymptote, cotangent is going to have a point on the sinusoidal axis. So when you're graphing cotangent, it's the same thing as tangent, especially the high and the low points. But wherever tangent has an asymptote, cotangent is going to have a point on the sinusoidal axis. And vice versa. Wherever tangent has a point on the sinusoidal axis, cotangent is going to have a vertical asymptote. And to see that, I can graph here in black what tangent would look like. So tangent has a period of pi. So if we go pi over 2 this way and pi over 2 that way, and then graph tangent, you could see, all right, this is where tangent crosses the sinusoidal axis, and cotangent in green has that vertical asymptote. Here, this is where tangent has a vertical asymptote. Cotangent hits the sinusoidal axis. Right, both of these points have the same high point right here, And if I graphed another period of tangent, they would both have a low point right there. All right, so when graphing cotangent, you could think of where you start as on A. So you go A, H, M, L. So asymptote, high point, middle, low. Asymptote, high point, middle, low. And if we look at these directions here, right, we're going to draw the sinusoidal axis by looking at the vertical shift. Okay, then mark A from the sinusoidal axis. All right, so by looking at this leading term right here, and that's going to be where our 3 points are going to go vertically. All right, then start from the first asymptote. So wherever we start, it's going to be an asymptote, and then we count 1, 2, 3, 4, and then that fourth point is going to be the next asymptote. All right, and then the pattern is decreasing unless it's reflected, but if it's not, it's going to decrease. So it goes high, middle, low. All right, so now let's do 2 together, and then you can try the rest of these on your own. So here we're going to graph 3 times the cotangent of 2x. So let's fill out this table on the left. So we have A, right? That's going to be 3 because that's the multiplier. That's the vertical shift in front of the cotangent of 2x. All right, B is going to be 2 because it's the number in front of x. All right, period is pi over B. So pi over 2. So our increment is going to be that divided by 4. So pi over 8. So dividing by 4 is the same thing as multiplying by 1/4. The sinusoidal axis is going to be 0 because there's no vertical shift. So we're going to mark that point of our sinusoidal axis on the x-axis. Then we're going to move up 3 and down 3 to mark the high and low point. Then we want to set up our x-axis. So since we start on the y-axis, because there's no horizontal shift, right? There'd be a horizontal shift if you were like adding or subtracting something from 2x here, but we're not. We'll do it in the next problem. All right, so we've got for our starting point, which is the origin, and then we're going to move our increment over. So this would be pi over 8. This would be 2 pi over 8. This would be 3 pi over 8, 4 pi over 8, which I could simplify to pi over 2. All right, and now we can put it all together. So I'm going to start with the vertical asymptote because the tangent of 0 is 0, so the cotangent of 0 is going to be undefined. All right, then our next point is going to be a high point, middle, low, and then vertical asymptote, right? Because cotangent decreases. All right, so you could think, all right, if you want to double check, you could plug in pi over 8 for x, and you get 3 times the cotangent of 2 times pi over 8, which is pi over 4. So that's 45. So the cotangent of 45 is 1 because the tangent of 45 is 1, and the reciprocal of 1 is 1. Right, and then we get 3. So you can think of, right, that first quarter of a period is always going to be your high point. And then it decreases to middle, low. And then this right here would be 1 full period. And that's it. And the only thing that will change, make this a little harder, is a starting point, which we'll look at the next example. All right, but let's finish it with the asymptote. So we have one asymptote at x equals 0, and another asymptote at x equals pi over 2. Now, if it just said to write 2 specific asymptotes, that would be fine. You could write it like that. But if you wanted an expression to write all the asymptotes, since they repeat every period, so like this would be a period, which in this case is equal to pi. Or if you go this way, right, pi units 1, 2, 3, 4. Okay. Another way you can express it is take one of the asymptotes, which we can use 0, add the period times k, where k is an integer, which means you'll have a asymptote every pi multiple of pi. So x equals pi times k, where k is an integer, will represent all the asymptotes that occur on this graph. All right. So let's do one more with a horizontal shift. But before you watch the rest of this video, I suggest you try number 6 and check the answer key. All right, so take a moment, try number 6 on your own, and then check the answer key. And if you're not sure what went wrong, just ask for help. All right. So here's another one you could try on your own. Here's a tangent with the horizontal shift. So you could try that as well on your own. Check your answer key. All right, but I want to do this one together, cotangent with a different starting point. And it's the same thing as tangent, just asymptote high, middle, low. So A is equal to 2 because that's the number in front of cotangent. So that's the distance that our high and low point will be from our middle point. All right, B is equal to 1/2. All right, this does not affect B. B is simply the number in front of X. All right, period is always going to be pi divided by B. So pi over 1/2, that's the same thing as pi times 2, 2 pi. All right, increment for every trig function is always 1/4 of the period. So 2 pi over 4 is equal to pi over 2. All right, y equals 0 is the horizontal asymptote. All right, because there's no shift up or down. And it's not a horizontal asymptote, I apologize. It would be the sinusoidal axis. But in this case, there's no sinusoidal axis because it's tangent. So we're just going to start vertically on our x-axis. And we're going to move up 2 and down 2. And now we're going to set up our x-axis. So our starting point, so SP, is going to be at the x value that makes whatever's inside the parentheses equal to 0. So 1/2 x plus pi over 4 equals 0. So we can subtract pi over 4 and then multiply both sides. There's an x here. And then multiply both sides by 2. And we get x equals negative pi over 2. All right, so I just set what's in the parentheses equal to 0 and solve for x. So our starting point is at x equals negative pi over 2. Now, luckily, our increment has the same exact denominator, so we don't have to get a common denominator. So we're going to mark off negative pi over 2. And then every pi over 2 is going to be another increment. So 0, pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. If we go in the other direction, negative 2 pi over 2, negative 3 pi over 2, negative 4 pi over 2, which is negative 2 pi. All right, so every tick mark on my x-axis is equal, has a distance of pi over 2 units between them. So now we're going to start right here on our starting point with a vertical asymptote because the cotangent of 0 is undefined. And we just proved over here that if you plug in negative pi over 2 in for x, it'll make this equal 0. All right, and then we go to our high point. So we move over an increment and then go to our high point. So we're here. Move over an increment to our low point. Move over an increment, middle point. Move over an increment to our low point. Move over an increment, and we're at an asymptote. And this right here would be one full period of cotangent. All right, if we wanted to go in reverse, we would go, we'd go low, middle, high, and then asymptote. And then there's 2 periods. All right, so that's it. Finish these problems up and check your work with a graphing calculator, or there's an edge key provided as well. But try the graphing calculator first. It's good to know how to use that. And if you're not sure, please ask and I'll be more than happy to help you. All right, that's it. Hope you enjoyed the video and have a great day.